Hi, in this video I'm going to talk about information which Stata secretly stores after you run certain commands. So this information is called stored information, and to show you what it looks like in the help files, first of all, I'm going to pull up the help file for summarize, which is one of the commands which stores information. And if I scroll all the way down to the bottom here, there's a section called stored results. So you can see things like rmean here. It stores the mean from when the last time you ran this command. RSD stores the standard deviation from the last time you ran this command, etc. So to show what this looks like in practice, I have this data here, which is auto.dta built into Stata. So if I summarize the prices in this data set, sum being short for summarize, so it gives this average, so cars cost $6,000 on average, how quaint. So if I wanted to then print this number on the screen, of course I could say display, and then I could type the actual value of it. But to show you that Stata has stored that value as rmean, I'm going to say print whatever the value is of rmean, and Stata is going to print 6165 point blah, blah, blah. Same thing, I could tell Stata to display. We saw that RSD was the standard deviation. So if we say display RSD, then it's going to print this number on the screen. Okay, so you can also use this not just to print these values on the screen, since they were already printed here. Of course, you could use this to do calculations with it. I could display RSD times 10 million if I wanted. And then another thing which you can do with this is you can create new variables using this information, right? So if I wanted to have a new variable which took the value 2949.496 or whatever this standard deviation had been, then I can say gen sd equal to rsd. And when I go browse here, there should be a new variable on the far side here which has exactly the value 2949 and is called sd. Okay, so what's the reason for using this stored information? What's the rationale for doing this? Well, one is that it can be faster just to type this than to type in the exact standard deviation. That's not a big time savings in this particular example. But so there are a couple of other reasons why you might use this related to just sort of good practice with using do files. So if you write out a do file for someone else to read, which you want someone else to read, and you want them to be able to understand the structure of what you did in your do file, it'll look kind of arbitrary if you generate a new variable equal to 2949.496, right? They would have to run the code to know where that number came from. But somebody who is just looking over the code without running it would know that what you did here was you created a new variable equal to whatever the standard deviation had been when you summarized the price. Similarly, when you're running a do file, or when you're writing a do file, if you make some changes before this command, it's nice to not have to go back and edit this to have a different number here, right? So if you made some changes such that there was a different standard deviation in this command, it would be nice to not have to go back and alter the exact value here. And if I write this command so that it's equal to whatever the standard deviation was from this previous command, then I don't have to edit this if I edit previous commands, which will change the value that this takes. So it's a shortcut for workflow. Okay, so that's the rationale for why you might want to use stored information. I'm going to show you now the command which I would say probably people use stored information from the most, which is regressions. So I'm going to run a regression of price on miles per gallon. You'll see that cars which have high gas mileage tend to be cheap. It's probably due to omitted variables bias from the fact that small cars tend to get really good gas mileage, but also tend to be cheap. So I have this regression estimate here from the regression of price on miles per gallon. And the first thing I want to show you is that the individual coefficients are stored as _b, and then in square brackets, the name of whatever the variable is. So in this case, if I wanted to get the coefficient on miles per gallon, that's stored as _b square brackets mpg. If I wanted the coefficient on the constant, I could do this exact same command, but with _cons. So this will print that coefficient. I could also do this for the standard errors, for example. You can get lots of information out here, right? So there's the standard error from constant gets printed down here. Lots of other information. You can look through the help file to find more pieces of information if you want to retrieve anything else which is up here. But something which is handy is that you can even use all of this stored information, well, particularly these coefficients together, to generate predicted values of the y variable based on the regression model and the values of the x for each observation. So I'm going to say predict y hat, well, I'll call it price hat. So there's a convention in econometrics that if something is estimated, you put a hat over it. So I'm calling this price hat because this is the price which is estimated for each observation using this model based on that observation's value of miles per gallon. So if I say predict price hat, that's going to create a new variable which is equal to the prediction of price using that regression model. So I'm going to go into the browse window and you can see over here that there is a new variable here called price hat. You can see some of these observations take the same value. So the reason why they would take the same value is because they have the same miles per gallon. They don't have the same prices, of course, but so long as they have the same miles per gallon, since that's the only variable which was input into our regression model, they're going to have the same prediction about price. So this lets you get out your regression model estimates. If you wanted to get the residuals from the regression, you can do, I'm going to create a new variable called resid using the command predict, and to get the residuals instead of the predicted values, I'm going to use the option $R. So now this is going to equal whatever the difference is between the actual price and the price which we predicted out of our regression model. So if you go all the way over here to the right, there you get your residuals, and of course some of them are positive, some of them are negative. On average, they'd better be equal to 0. Okay, the last thing I want to show you is that when you run more than one command which stores information, the moment you run a new command, the stored information from the old command is lost. So I'm going to show this to you. So you remember we had this RSD, which was the standard deviation taken when we summarized price. If I run this command now, you'll see Stata prints nothing on the screen. So RSD is now empty. All that stored information from summarize before got wiped out the moment we ran the command regress, which stores its own set of information.